now I'm delighted to welcome Brian Maybin, who is Head of Advanced Technologies at WrightBus, who's going to talk to us a little bit some of the challenges that we have maybe on the consumption side.
We are a designer and manufacturer of city buses. So we were formed 75 years ago in 1946. We're based in Ballymena in Northern Ireland. We are the manufacturer of the iconic new bus for London. We launched our first battery EV vehicle in 1999 and our first fuel cell EV vehicle in 2008. In 2019, we came under new ownership and were owned by Joe Bamford of the Bamford JCB family. We have an updated factory facility with significant capacity for growth. And we're very focused on zero emission buses, but we're focused both on battery EV and fuel cell EV. We believe that each of these technologies has pluses and minuses, and they're suitable for different environments. Two iconic projects we did in the past was the 1,000 new Routemaster hybrid electric vehicles in London and the streetcar hybrid electric 18-metre bus rapid transit vehicles for Las Vegas. I'm just going to share a few details about our zero emission product roadmap. This is our Generation 1 fuel cell EV double deck. Amongst other cities, there's 15 of these running in Aberdeen. This came on sale in 2020. Around 50 buses are already delivered and running on the road, and around 100 further bus orders are in place at the minute, and more will materialise. As I mentioned, we're also focused on battery electric. This is our Generation 2 battery electric vehicle. It's a double deck. This new vehicle is being launched in June 2021. It's available with the largest battery capacity in the UK industry for a double deck, which gives it the longest EV range. And 80 of these buses have been ordered by TransLink, the local operator in Northern Ireland. This is our Generation 2 fuel cell EV single deck, which is being designed at the minute. A driveline test mule for this new fuel cell EV technology demonstrator is being developed under the APC, Advanced Road to Market Demonstration Programme. And this test bus will be displayed at the Cenex Low Carbon Vehicle Exhibition in September 2021. We also have involvement in Advanced Propulsion Centre 17 programme. And under this programme, which will start for us in May 2021, we plan to develop a complete new family of fuel cell EV buses, utilising new driveline technology and an integrated supply chain. And these are designed for export around world markets. So we're going to have a new fuel cell EV 12-metre single deck bus, a new fuel cell EV 18-metre articulated bus, a new 10.6-metre 2-axle double deck, and a new 12-metre 3-axle double deck. And there's very much a pull in the international market for these types of vehicles. There's more demand than there is supply, and this gives WrightBus lots of opportunities for growth and for export. So what is a fuel cell EV? A fuel cell, to start off with, is a solid state device that converts hydrogen from onboard storage tanks and oxygen from the background air into electrical energy. That electrical energy is then used to charge a small battery. And from that point onwards, it really operates the same as a battery electric vehicle. We have an electric traction system, and the battery allows the recuperation of energy during braking. The only emission at the point of use is distilled water. Some waste heat is created, which is very useful because in the winter we can use that to heat the passenger saloon. The hydrogen refueling process, so a complete fill of hydrogen, takes between 7 and 8 minutes. And hydrogen, as Colette mentioned before, can be produced from surplus renewable electricity. And this is classified as green hydrogen, and it also helps to balance the electricity grid. Some advantages of fuel cell EV over battery EV, especially in the bus market. The bus daily range is typically much higher. A battery EV vehicle, even our vehicle with 432 kilowatt hours of batteries, can only achieve 190 miles. Now that's okay for inner city and somewhere like London, but routes that are intercity or rural routes, it's nowhere near enough. And the problem is more batteries means more weight and more cost. The fuel cell EV can easily achieve more than 300 miles. The fuel cell EV performs much better when the passenger heating is needed in the winter, and it's very suitable for places like Dubai, Hong Kong, places where hot climate and you need aircon. Refueling time is only 7 to 8 minutes for fuel cell EV, whereas 3, 4, even 6 hours is needed to charge a battery electric vehicle. Buses want to operate 22 or even 23 hours a day. Fuel cell EV is the only option if the bus garage is far away from a 33 kV electrical grid supply. 100 buses can need the same electricity supply as 5,000 houses, so it's pretty significant amount of electrical energy. For a 100 BEV bus garage, significant additional land is needed to allow the installation of all the individual EV battery chargers. And probably important for WrightBus is that there seems to be many more international opportunities for us to sell fuel cell EV buses compared to battery EV buses, which is dominated by Chinese bus suppliers. So the map on the left shows some hydrogen production sites. Some of these are brown hydrogen, blue hydrogen, and some of them will be green hydrogen. The long-term plan is that we want to harness surplus wind power to produce green hydrogen. However, much more investment is needed in the UK green hydrogen production and distribution system. And this can only be really achieved through government coordination. So how do we, until the natural gas pipeline conveys hydrogen, how do we actually get the hydrogen into the buses? It's actually reasonably straightforward. The image on the left shows a 2-trailer system. So you have, you're using one trailer, and these are hydrogen tube trailers to fill the bus, whereas the other one is being replaced. They broadcast their remaining capacity using telematics, which means the truck turns up before it's needed. The image on the right shows what you need for 100 buses per day. So if you have a rural bus operation, this is easily achievable rather than having to connect to a 33 kV electrical cable. Just for the engineers involved in the audience, a few details about components. This is our single deck vehicle. At the front of the vehicle, we do need a lithium battery to deal with the peaks and troughs and energy demand, and it needs cooling. We have hydrogen storage tanks, which store around 38 kilograms. We have a version for 50 kilograms as well. So that allows easily more than 300-mile daily range. We have the option of a 70 kilowatt fuel cell at the minute, or a 100 kilowatt fuel cell. That's the black item at the back. And of course, we still need an electric traction system in the same way as a battery electric bus. So we need a permanent magnet drive motor, we need a drive inverter system, and we need a high voltage power distribution system. So that was the slides that I wanted to cover.